Hello, Chemistry 10 and Chemistry 10H students. This is Mrs. Altman, and in this video, I will be reviewing how to use the solubility rules sheet in order to determine if something is soluble or not soluble. So you will want a copy of the solubility rules with you, and then you may also want your periodic table and a polyatomic ion sheet, though those are not quite as important as the solubility rules sheet. So solubility just describes if something will dissolve in water or not. So if it is soluble in water, it's going to dissolve in water. And if it is insoluble in water, it is not going to dissolve in water. So for this course, I gave you a list of solubility rules. And even though I gave you those rules that are in real life sort of exceptions and things that are between being soluble and insoluble, but these are largely true and can be really good predictive measures when we're working in a lab setting. So for this class, I'm not going to make you memorize them. You just need to know how to use them. So I'm going to just quickly change my screen over to the solubility rules. So you probably in class, I demonstrated this, but we want to add NH4 plus to the exception list here. For whatever reason, it's just not listed. But otherwise, we're going to look at a bunch of examples together. You're also not going to need this section down here. It's not that it's wrong, you just don't need it. So if you want to cross it out so as to avoid being confused, please go ahead and do so. All right, let's work through some examples together. So the first one says lithium phosphate. So I go over to my sheet and I see the first rule says lithium. So I'm going to look right there. And it says always soluble with no exceptions. So right then, I don't have to do any more digging. You're never going to see any sort of case where they contradict one another. So this is going to be soluble. Now I've got iron 2 chloride. So I'm looking first. I see all sorts of things. I don't see iron. So if you end up in that situation, it's totally fine. You're going to look at the second one. So look for chloride. And I see that chloride, chlorine minus, is mostly soluble. It does have exceptions. I check. So I've got Pb, Ag, and Hg. Iron is not an exception. So it is going to be soluble. You're never going to write mostly soluble. It's always going to be either soluble or insoluble. Now I've got silver 1 chloride. So I don't see silver on here. I always start with the leftmost column. You're never going to start with the rightmost, always with the leftmost. I don't see any silver. So now I look for chlorine. Okay, so I have chlorine right here. It's mostly soluble, but silver is an exception. So whenever you have the exception, it goes against whatever this rule is. So instead of being soluble, it's going to be insoluble. And now I've got potassium carbonate. So I see potassium is in my first rule, but let's pretend I didn't notice that just because I want to show you something here. Let's pretend I didn't see the potassium was there. I see that carbonate is here, and it's mostly insoluble, but potassium is an exception. So instead of being insoluble, it will be soluble. Let's look at another example, but here we're also going to write the formulas. So the first one is potassium sulfide. So potassium is in group 1 for the periodic table, so it takes a +1. Sulfur is in group 6. Then I crisscross applesauce. So the formula is K2S. Now I'm going to look at my solubility rules. Potassium is in the first rule. It's always soluble, no exception, so that has to be soluble. Now the second one, I've got calcium phosphate. So calcium is with a 2+ charge. Phosphate is from the polyatomic ion sheet. It's PO4 with a 3- charge. Remember your parentheses here. Now I'm going to check my solubility rules. All right, so I don't see calcium, but I do see phosphate. It is mostly insoluble. I check my exceptions. Calcium is not an exception, so this is insoluble. On to my next one. I've got lithium chloride. I've got Li with a +1 charge, chlorine with a -1 charge, crisscross applesauce. They end up canceling out, and I got LiCl. Now I check my solubility rules. Lithium is in the first rule. It's always soluble, no exceptions, so that has to be soluble. And then last one in this example, barium hydroxide. So I've got Ba, which takes on a 2+ charge. I've got hydroxide, which comes from my polyatomic ion sheet. Crisscross. Remember your parentheses. Oftentimes students forget with hydroxide because there's no numbers in there, but you still need them. And I check my solubility rules. So I look here, I don't see barium, but I do see hydroxides. They are mostly insoluble, but barium is an exception, so that means it is soluble. Let's take a look at our last example for the video. So again, very similar to the first couple of examples, we're just looking at the solubility rules to determine them. So I look at my solubility rules. NH4 is in that first rule, so it is always soluble, no exceptions. Next, I have PbCl2. Right, so I'm looking at these rules. I don't see Pb, but I do see Cl. Cl is mostly soluble, but Pb is an exception, so that is going to be insoluble. Next, I've got MgCO3. Looking at my solubility rules, I don't see Mg, but I do see CO3, which is mostly insoluble. Magnesium is not an exception, so it's going to be insoluble. And then the last one, NaC2H3O2. So I look at my solubility rules. Na is in the first rule, always soluble, no exceptions, so this is soluble. All right, that is all for tonight's video. Thank you so much for watching, and have a great night.